Okay, we're in section 6. It's inverse trigonometric functions. We completed the material here, again, to remind you that you're supposed to, review what was covered in class and then do the supplemental problem set and then do the WebAssign. And that would be Math 120, topic 6. Also try to enter something into the weekly discussion group. So here's the deal. We've discussed about inverse functions as they were discussed in Math 119. We went through that business over there. We just reminded you what you did in Math 119. Then, of course, what we did was you talk about the inverse trigonometric functions. I'm of the opinion that it's not a good idea to memorize stuff. However, some students want to memorize things, and there's nothing wrong with that. I just think it's a good idea. What did we do? We went through some really simple examples about invertible regions. What did we try to do? Stay close to the origin and find an invertible region on a non-invertible function. And we did that for all 6 trigonometric functions. We talked about domain and range, and basically what we did was we just rehashed what you learned in Math 119. Then what did we do after going through the sine, the arcsine, the arccosine, arctangent? We did not do the other 3. However, they can be done, but we don't do those. All right. So let me just quickly go through that. Again, we went through all that stuff in class. Then we went to problems. And the problems we did in class. We're hoping you understand those questions. Now, certainly some students say, well, do I really need to understand that? Yes, you do, because you're going to need to move forward. And moving forward means that you understand what's presented to you. That's part of the study process. All right, so we went through this in class. We went through it on the whiteboard. There's also little embedded videos over here. If you want to watch that, if it's helpful, please do that. So we went through a bunch of problems and then, eventually get to the end of these things. There was some Sage code there as well that was discussed. We talk about supplemental activities. You should think about, maybe stepping outside of what you're doing at Essex in the classroom and, looking at your textbook. Certainly that's available to you on WebAssign. And you should also be discussing these things with students outside of Essex County College. And the internet's a great place to do that. There's plenty of websites out there that discuss this level of mathematics and offer help. Again, the more time and effort you put into this, the better. Now, of course, there's homework. You need to reinforce what you've just learned. So what I'm going to do is I'm going to go to the whiteboard. In 1 second. I'm going to do the problems. You're expected to have done the problems already, though. All right. So if you're watching this, I'm hoping that you say, yeah, I've done this already. And maybe you need help with a few of the problems. Well, watch through. You can always fast forward in the tape as well. But I got to get the whiteboard open, right? So let's do that. And just give me a second to do that. Okay, I'm on the whiteboard. Now, of course, someone's going to say, hey, where'd the notes go? You have possession of the notes. You should. And the reason for that is that, the bottom line is these notes have been given to you since day 1 of the class. So I'm going to write down, we're in section 6 of the notes, section 6, and we're doing the homework. Okay, let's put number 1 down. And number 1, it says, on what interval is the identity arcsine? I'll write this over here. Arcsine of the sine equal to x. For what interval is it valid? Well, again, what we do is we look at the invertible region of the sine function, and I'm hoping you may not remember what that is, but you remembered how we did that. And what we did, we drew an invertible region of the sine function. Well, we did this over here. All right. So what was that? Again, this is the sine function, the invertible region of the sine function. And it started at minus pi over 2, and it stopped at pi over 2. All right. So, the arcsine is going to undo the sine and return x. They're inverse functions. And certainly in Math 119, you were kind of told this. Or if you did this over here. By the way, that's only true on the invertible region. We get the eraser out. That's a little review of what you did in Math 119. Erase this over here. And so this is only going to be true on the invertible region. Well, what is the invertible region? It's between minus pi over 2 and pi over 2. After I finish the homework, what I'm going to do is I'm going to graph this. And what you're going to find out is that the line y equals x would only match this curve here, this graph over here. Maybe I'll put y down here, y1, y2. Oops, arc sine, sine of x. These two would only match on that interval. Otherwise, you're not matching up arc sine, okay? Let's look at the answer key. Let's see if we got it right. I'm looking at it, and I feel good about that. We go to number 2. And number 2 is a question. Oops, sorry about that. It says without using a calculator. Well, I'm not going to use my calculator. What do they want to know? Arc sine minus 1 over root 2. And again, you should have some reasoning skills, and you don't have to resort to using a calculator because they say don't do that. Again, what I would do is I just remind myself, I want to point out what this is over here. This is a ratio. And we're wondering what's going to be the angle that's going to be returned over here. What's the theta over here? Well, I'm going to just encourage you again is invertible region. And that invertible region is between minus pi over 2 and pi over 2 for the sine function. What I would do is I'll look for the ratio. And what's the ratio? Well, the ratio is minus 1 over root 2, roughly speaking about minus 0.7. So I'm going to say over here somewhere. All right. Then the question comes is, do you know what that angle would be? The reference angle, I'll write this over here, would be 45 degrees. That's the reference angle. And why is that? Well, if we did a 45, 45, that would be 1, 1, root 2. We would certainly get the ratio 1 over root 2. But again, I'm pointing out that this is not the angle. This is just the reference angle. What's the angle going to be? Well, it's going to be minus 45 degrees. I'll write that down for you. Or if you prefer, in radian measure, which we really should be speaking, minus pi over 4. Let me get my red ink out, see if I did this right. And I did it. All right. That is, again, it emphasizes that's an angle for us. All right, let's go to number 3. And I'll put down number 3 for you. And this one's a little bit different, but on the same, level. It's arc cosine of 0. All right, I want to point out this is a ratio. And what are we looking for? We're actually looking for the angle theta, all right? So what I want to do is I want to put the invertible region down for the arc cosine. And it looks like this over here. All right, which goes between 0 and pi. What am I doing? I'm looking for the ratio of 0. And that occurs right over here. Question is, where did it hit it? Well, it hit it at pi over 2, or 90 degrees. I'm going to put that down for you. So the theta here is going to be 90 degrees, or pi over 2. Put a box in this, put a box in this. Get my red ink out. I'm going to check it. And this is number 3. And I'm clearly seeing that as an answer. And again, that's an angle. Let me go to number 4. Again, these problems should seem relatively simple if you've attended and understood what was presented to you in lecture. All right, so what's number 4? It says, without using a calculator, evaluate the arctangent of root 3. Now, I will say over time, you're going to get faster at this, but right now, our intent is not speed. Our intent is, do you understand how we did the problem? Well, again, I'm going to put the invertible region of the tangent function down. And that occurs between minus pi over 2 and pi over 2. My pen's acting up. Give me 1 second. I have to screw my pen back in. That's a weird one. What's going on there? But anyway, give me a little time to think, right? I might have lost connection with my pen. Plug it back in. Just give me 1 second. Plug it. Let me see what's going on here. Oh, there it goes. It came back. All right. So then the question is, what are you doing over here? You're looking at the ratio. The ratio is clearly a positive number. Trace over, and we're going to try to find out what the angle is, right? What's the angle theta? What is it? So I want to remind you, looking at this thing, you're talking about the arctangent, and I wonder what would give the ratio of root 3. Well, the ratio is root 3 over 1. You should recognize that. I'm going to put the reference triangle down, root 3, 1, and that reference angle would be 60 degrees. All right, this is the reference angle, reference. Now, certainly looking at it, what do I know about this angle up here? It's got to be between 0 and 90 degrees. So 60 seems like a relatively simple answer. I'm going to write down the radian measure. Let me put that down for you. 60 degrees times pi over 180 degrees, which would be pi over 3. All right, put a box in this, put a box in this, get my red ink out. We're on problem number 4, and I'm going to check it. 60 pi over 3. All right, let's keep going. I'm going to go to number 5 now. Again, we're not trying to trick you. We're trying to just reinforce what you've learned in class. This one says, using your calculator, evaluate the arc sine of 5 over 7. Again, when I do Sage, I'll show you what happens in Sage, but any modern level calculator, if you were to type this in, the arc sine of 5/7, it would respond arc sine 5/7. That's how it would respond to you. Now, of course, we need to force it to return back an approximate answer, all right? So in some sense, how do you know that? Well, I see the footnote. It says approximate to the 4 decimal places. So on a calculator, and I'll do this in Sage as well, you'd have to type in 5, divide, and then you got to put a decimal down somewhere. Either it's on the 5 or in the 7. And then your calculator is going to return approximate. If you're in the degree mode to 4 decimal places, you get 45.5847 degrees. If you're in radian mode, what would you get? 0.7956. All right. I want to point out, make sure you're looking at the key. If you can't get these answers for whatever reason, including you don't know how to use a calculator or a computer, reach out and we'll try to help you with that. So 45.5847 and 0.7956. Looking good. And we'll get a Sage later. Don't worry about that. All right. Let me go to number 6. Number 6 looks like a relatively same question. And what do they want to do? They want to do the arctan of 5.894. Again, certainly looking at this as a calculator exercise. And again, you should be able to use a calculator. If I'm in the degree mode, and again, I'll do this in Sage later, that would be 80.3707 degrees. And if you were in the radian mode, it would be 1.4027. And again, I'll do that later on Sage, all right? So let's keep pushing this thing up. Relatively simple question. I'll put boxes on that too. By the way, look in your answer key. It's certainly in the answer key as well, all right? I'm going to go to number 7 now. And what's number 7? Number 7 is use the properties of inverse functions. Well, I'm going to write it down for you. And certainly there's a variety of ways of doing this. I'm not saying that there's only one way to do a problem, but there's only going to be one answer. And that's 17. Oops, I get it right. It doesn't look right. 17 pi over 4. So what I want to encourage you, it's a big number. But if you look at 17 pi over 4, what is it? It's really multiple of pi over 4. And there's going to be 17 of those. So I'm going to just simply go through that with you. Pi over 4 is 45 degrees, right? So this would be 8 times 8 pi over 4. If I go one more round, that's going to be 16 pi over 4. Then I got to go over here. So what I'm going to say over here is that 17, whoops, I did it again. I'm going to say 17 pi over 4 is coterminal with pi over 4. All right, so I'm going to write this down now. Arc cosine tan pi over 4. All right, now what's a tangent of pi over 4? It's going to be 1. So let's write that down. Arc cosine, whoops, of 1. Now what I'm going to do, I'm going to draw the invertible region of the cosine function, which is this region over here. That doesn't look right, does it? And then the question is, where does it equal 1? The ratio would equal 1 up there. And what is that angle? It's 0, or if you prefer, 0 degrees. All right, put a box on those. And I'm just going to get my red pen out and see how I did. And I'm seeing both answers, and that's good news. Let me go to number 8. Again, I'm looking directly at the notes, and you should be as well. And what's number 8 say? Use properties of the inverse functions, find the exact value. Let me write this down for you. Arc cosine of sine minus pi over 4. I'm going to do some of the simple stuff I can do. The sine of minus pi over 4 is minus 1 over root 2. And again, what I'm going to do, I'm going to draw the invertible region of the cosine curve. Looks like this over here. And where does the ratio equal minus 1 over root 2? Right over here. And again, you should feel comfortable. I'm not saying these are accurate pictures, but you should feel comfortable that this angle over here is between 90 and 180 degrees. Now, granted, my picture is not drawn to scale here, but it's actually what would give that ratio would be the reference. I'll write this over here. The reference angle would be 45 degrees. Now, certainly if I'm between 90 and 180, I can't say 45. But if it's a reference 45, what would it be? 135 degrees. Or 3 pi over 4. Put a box in this. Again, I want to encourage you to look at the answer key to see if you're staring at those answers. And if you're not, you know there's something wrong. All right, whether it's wrong what I've done or wrong with what you've done. But something, if we're not in agreement with something, is definitely wrong. All right, I'm going to number 9. These are relatively simple questions if you've attended and understood the lecture. Now, this one says cotangent. And then they got the arc tan of 7/8. All right, some people get very confused by this. Now, certainly, I'm not saying you can't be confused, but you want to try to lift that fog off your head. And I know they're talking about the arctangent function. And if I were to do that, I'm going to say it looks sort of like this over here, the invertible region of it. And what do I know about it? I know there would be a ratio of 7/8 somewhere. And if I trace it over, and I'd get some angle here. Now, what do I know about the angle? The angle is going to be between 0 degrees and 90 degrees. So I'm comfortable in drawing what I consider to be a simple right triangle to represent that. All right, and this is going really back to the beginning of the semester. And what do I know about it? I know it's 7 here and 8 over here. And this would be the angle theta now. And why is that? The tangent of that angle would be 7/8. Now, what's the cotangent of that angle? It would be 8/7. All right, I'll get my red pen out. I'm going to look at the answer key and make sure I'm staring at that. All right, let me go to number 10. And what's number 10 say? Cosine of the arctangent of x. Again, I want to point out over here, the x is actually a ratio. All right, it's a ratio. And the arctan of x, this whole thing over here, would be some angle theta. So really what they're asking is a cosine of that theta. So the first thing I want to do is the invertible region of the arctan function. That looks like this over here. It's between minus 90 degrees and 90 degrees. Now, what do I know about the cosine curve between that? Now, certainly, if I look at the cosine curve, it would have to be something like this over here. So I'm going to say over here, so no matter what value I pick for the angle, the cosine of it would always be positive, which actually helps me a great deal. They're saying, hint, sketch a right triangle. So I'm going to put this down. The ratio is actually x over 1. I'm going to put a right triangle. This is a reference triangle now. And what's a reference triangle going to be? A right triangle where the tangent of that angle would be the ratio x1, or the hypotenuse being, pretty simple. It would be, let's see, x squared plus 1, right? That's Pythagorean theorem, the square root of that, by the way. And this would be the angle theta, right? This is the reference angle. Now, whether the reference angle is, in this quadrant here or that one over there, it really doesn't matter much. The cosine between those two numbers is always going to be positive. So what do we get over here? I'm looking at it. And what's the cosine of that angle? Well, it's going to be 1 over the square root of x squared plus 1. Don't worry about there being a radical in the bottom. We really don't mind that at all. All right, let's get my red pen out. I'm going to look at it, and that's the answer I'm seeing in the answer key. Let's go to number 11. Number 11, a little more complicated. And again, I'll be going to Sage after I do number 11, I believe. I think 11 is the last problem. What do I have? Y equals, this is 3 arc sine x minus 5. That's either read as arc sine or sine inverse. All right, depending on how you want to do that. Now, what's the first question? The first question, A, is what's a domain? What do I know about this over here? The ratio x minus 5 has got to be between 1 and minus 1. Well, I'm going to add 5 to all sides. And I'm going to say, this certainly, this, if you want to put that down in domain, you can. I'm also going to write the intervals down, 4 to 6. I'm going to go to Sage. I'll graph that out for you too, so you can see that it's between 4 and 6. Let me go to B. What does B say? What's the range of it? Well, the range is going to be, certainly it has something to do with the arc sine. And if you think about the arc sine, what it can return is numbers between, the arc sine, these are the angles between minus pi over 2 and pi over 2. But the deal about this one is we're actually multiplying it by 3. So both of these things will be multiplied by 3. So we get minus 3 pi over 2 up to 3 pi over 2. And that's going to be, this is an interval. This is a fine answer. I'm also going to write down y. Okay. And what's C? C says solve for x in terms of y. Well, the first thing I would do is divide both sides by 3. I would get y over 3 equals the arc sine x minus 5. I'm trying to solve for x, by the way. I'll take the sine of both sides. Sine y over 3 equals x minus 5. And I can solve for x now. What's that going to be? To 5 plus sine y over 3. Put a box in this. Look at my answer key. I'm going to look at it. And the answer key is what do I have over here? I've got this one. They didn't write the interval down, by the way. That's fine. I've got this one. And I've got this one. Okay. So I'm going to call it quits on the whiteboard, and I'm going to go to Sage now. All right. So I put the whiteboard away. I'm going to do another share with you. And I got to open up Sage, right? I'm hoping you're getting more comfortable with Sage. Again, you can use it from terminal application, web-based application, web-based notebooks. There's all kinds of ways of using it. I tend to like the terminal, and you should become more familiar with using Sage from a terminal application. I'm running version 9.1. Again, it's actually been updated. I haven't updated it yet. And it's the system of Python I've installed in my system is 2.7.15. That's also been updated. Some people like to update this stuff. I'm not a big user of Python or Sage, by the way, so I don't need that. But let me go back to my notes. And again, we provide code to you. And some of the code is, basically stuff that we've seen in the past. I'll go through this. Certainly, I'm not going to go through everything, but I'll go through some of that stuff over there. And part of it to give you the code is we're hoping that you too can actually retype this stuff and see what happens when you type it in. All right. So let me go back to my terminal. And let me scroll back on the notes. Give me 1 second here. And I'm going to scroll back. And you know what I want to do? I want to something a little bit simpler. I'm going to go to Grapher. I want to type this guy out for you. Okay. I'm going to type y equals arc sine of the sine of x. Now remember what we said about this. Let me get rid of Sage for a second. We said this is only valid between minus pi over 2 and pi over 2. All right. Now, someone says, what do you mean by that? You know what? I got to plug in my computer. I'm running on fumes, so to speak. Give me 1 second. Hey, Google, stop. Give me 1 second. Okay, so what I was saying about this over here, that this is only going to be valid between minus pi over 2 and pi over 2. Now, someone says, what is that? I just graphed it out. So someone said, what do you mean it's only valid for that? If I put down, y equals x now, and put that down for you, new equation, y equals x, you would see that these two curves only match between what we said it was going to match. And what did we say it was going to match between minus pi over 2? Well, that's over here somewhere. They match there, and they match all the way up to this up here, which would be pi over 2. Now, if we did something different, I want to point out, if, like, let's say we did our cosine, and certainly I'm hoping you can reason through this, our cosine and cosine, right? Oops, a little far there. This will only be valid on that invertible region, so between 0 and pi. Let's take a look at that. So I want to pull this over here, and I'm just going to pull the graph around. And I'm going to say that line, y equals x, only matches that sawtooth curve, which is this curve that we just graphed out between, certainly between 0, and this is a pi over here, right? You could do the same thing for tangent. Let me put that down for you. Arctan. What's the invertible region for that? Well, between minus pi over 2 and pi over 2. And what do you see over there? Exactly what we expected to say. It's only matching. I want to point out, I'm looking at two separate graphs. This is the graph of y equals arctan of the tangent of x, and this is y equals x. I'm hoping you see they're only matching between minus pi over 2 and pi over 2. I'm going to keep going through the notes, and I'm going to start using Sage now. All right, let's take a look. I want to do Sage, right? So, whoops, I just did it again. I'll do number 2. I'm going to reset, and then I'm going to put arc sine, and minus 1, divide by the square root of 2. It's minus 1/4 of pi, which is exactly what you said it is. And again, I'm not going to convert it for you, but you could if you wanted to. Let's do this one over here, arc cosine. Whoops. Of 0, right? I said that was going to be 90 degrees or pi over 2. So what happens? Pi over 2, all right, half of a pi. Let's do this one over here, arctangent of the square root of 3. What do we say it's going to be? We said it's going to be 1/3 of a pi. 1/3 of a pi, exactly what they said. Let's do this one over here. I'm going to show you what happens when I do it on a computer. That's going to be arc sine. I said the computer's not going to do anything. Now again, this might do something wacky. No, didn't do anything. So what we got to do? Type it in decimal somewhere. Let me do that down for you and see what happens. Now I'm getting the approximate answer. What is going to be 0.7956. If you want to convert that number to degrees, I would just simply multiply by 180 degrees divided by pi. And let's see what happens if I do that. Oh, you know what? I got to numerically approximate pi. So let's take a look here. And whoops, I'm sorry about that. Give it a second. Hope I didn't type something in incorrect over there. Let me look at my code now. 1 second. Right? Maybe I can't remember. Oh no, I'm sorry. It must be. It communicates with server sometimes, and it hiccups sometimes. It really does. So what number are we on? Oh, right there, 45.58. Yeah, that looks pretty good. All right, let's do the next one up there. Let me just clear the screen out. And I want to do this one over here, arctangent Arctan, right? 5.894. Don't be intimidated. You can type. And what do I get? 1.4027. Looks pretty good. I'm not going to do the degree again. Let's do this one over here. This is arc cosine. Again, you really need to learn how to do things by hand, but you also have to learn how to use a computer. 17 pi. Divide by 4, right? And you get 0, exactly what you expected to come up with. Let's do the next one. Using the computer. Arc cosine. Oops. Sine minus pi divided by 4. And let's see what you have in there. Let's see, arc cosine minus 1/2. I wonder why it didn't do it. I'm going to look at it again. Minus pi over 4 sine. Let me try this. And let me try this. Star 180 divided by pi. What am I doing there? Oh, I know what's happening now. Let me just clear that out. Maybe I shouldn't clear it out. I just leave that up there. And just go backwards a little bit. So sine minus pi over 4 minus 1 over 2. Let me type this in, arc cosine. I'm really wondering why that's not working. Why it's not giving me the 135 degrees. So I'm going to put down minus 2. I'm just simplifying that. I don't want to type that whole thing out. No, for some reason, not returning it. All right, not returning it. Let me just do that n again. Oh, I got to do the pi. That's what's happening there. Now I see. Yeah, 135. Again, I don't know why I didn't do it. I really don't. Really, really don't. You know what? I want to go to Mathematica. Let's do that right now. I'm going to say Mathematica Wolfram Alpha because it's the free version of Mathematica on the online. And I'm opening up a browser. I'm going to go to Wolfram. And I'm going to type that in. And what am I going to type in? This one over here, right? Just pull that up a little bit. And let's get Wolfram going. And it's arc cosine. And then sine minus pi divided by 4. Little blinky lights here, as if it's working on something. It's really not. It's toying with this. Again, it's having issues with it too, which is great. I'm actually glad it's having issues with it. And I'll tell you why I'm glad having issues with it. That, oh, now I see. I didn't type it in right. That's why. Yeah, 3 pi over 4. All right. It's not having issues with it. Wolfram's not a bad thing to be using. All right, let's go to the next one. Let's do this one. I'll go back to stage in a second, but cotangent Arctan of 7/8. So it gives us 8/7. It's exactly what we expected to get. I'm going to go back to graphing. Oh no, let's see if we can do this one over here. So cosine arctangent. I'm just looking at problem number 10 now of x. See if you can do it. Yeah, it does it. It's great. It really does do it. All right, I'm going to go back to graphing. I want to do this one over here. I just want to remind you when I'm graphing, I'm going to graph using a software. Equals, it's going to be 3 times arc sine x minus 5. Let me get rid of this graph here. And I want to just pull this over here. I'm going to zoom out. I'm going to zoom into a certain region of it. And let me just do this over here, okay? Okay. So someone says, why'd you graph that out? I want to go through what we said the answer was. And I said the x was between 4 and 6, right? I hope you can look at this. The x is between 4 and this over here is 6. I'm going to put those lines in for you, though. So I'm going to say x is 4, right? You see that? And x is 6, right over there. I hope you can see what I just did over there. I said it's between 4 and 6, right? What I'm talking about, the graph is between 4 and 6 on the x-axis. What did I say the y is between? Let's write that down. I said the y was between, minus 3 pi divided by 2. Make sure you know what I just did over there. I put that line in. Remember, I said this graph is between minus 3 pi over 2 and 3 pi over 2. All right, I put that down. Yep, perfect. We did a great job. All right, let me go back to Sage. Let me clear. And I'm just going to go through the Sage code real quick. Reset. Okay, X's of R. I think we've done this many times before. You should be getting better at typing things in. I'm a little tired, but I will read it to you. Okay, let me just pull that over here. What does it say? It says plot the sine function and the arc sine function, where x minimum is -1, x maximum is 1, between, y minimum minus 1.6 and y maximum 1.6. You can play around with those numbers if you want. Again, this is having trouble coming up with the server, but it will do that in a second. And I'm hoping it returns something to me quickly. If not, I'll just have to call it quits on that. Hoping it returns something quickly. Yeah, sometimes Sage does this, by the way. Oh, there it goes. So it did it. What did it graph out? It graphed out what we expected to graph out. Whoops, sorry about that. It graphed out both the arc sine and the sine in the same window over there. And I'm kind of seeing that. Let me make sure I got that. Yeah, looks good. All right, so let's do the next one. I just go over the notes with you. I'm going to go back to Sage and the notes. Again, we plotted two functions, the same thing. Oh, this one looks familiar, doesn't it? We just did it, right? By the way, I really prefer Grapher to Sage. Right, I graphed it out. So what did you just graph out? The same thing we just did. Right? I like this graph better, by the way. But you might. It's up to you. You decide what you like. Let people tell you what you like. All right, let's go back to the notes. And Sage. I was looking through my Sage code over here. Well, let's try it. Cosine. I think we did this one already. I don't want to do it again, but maybe I should do it again. Arctan X. Yeah, we did that already. We did it in Wolfram Alpha, though. Cotangent. Let's see what happens over here. Of arctan. 7/8. It's nice to have multiple tools available to 8/7. You were expecting to see that. Arc cosine. Sine. I think we did this one too, right? We had some trouble with it. Minus pi divided by 4. Yeah, we had troubles with that one. All right, let's see what they say to do. Well, they just more and more code. All right. and also in conversions and stuff. All right, I called it quit there. I want to point out to you that Sage will not going to be tested on it. You should not be using Sage or any computers when you're doing an exam, unless you're expressly told to use Sage or a computer algebra system on the exam, right? You should be doing everything by hand, as we do in class and as I do in the majority notes, unless they tell me to use a calculator. So you're not to use a calculator, you're not to use Sage, unless you're instructed to do so. We're not going to test you on the use of Sage in this class. I do want to emphasize, though, using Sage is something you want to master, all right, including other software. Don't think there's only one piece of software that's going to cover it. It's not true. There's a ton of different softwares out there. Make sure you know that they're available to you. Once you start learning one, learning another is going to be easier and easier and easier over time. All right. Let me call that quits for you guys, and I'll see you next time.